and me uptown, dancing all around till the disco ball pops. But I have to be me, and everyone can see your anger is misplaced. And I'm gonna tell ya, don't hate me 'cause I get attention. Don't turn me into what I'm not. I have to be me 24/7, and I ain't never gonna stop. No, 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 no. No, 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 no. Oh, no, no, no. No, oh, oh, oh. And I ain't never gonna stop. Come on. Listen to me. I've tried so many times to tell you this is as good as I can be. Why isn't it enough to be faithful and also be the hit of the party? Let's just break it down to you and me uptown, dancing all around till the disco ball pops. But I have to be me, and everyone can see your anger is misplaced. And I'm gonna tell ya, don't hate me 'cause I get attention. Don't turn me into what I'm not. I have to be me 24/7, and I ain't never gonna stop. No, 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 no. No, 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 no. Never gonna stop. No, 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 no. Yeah, 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 yeah. I ain't never gonna
listening? Damn. Yeah. Yeah. Yeah.
Absolutely silliness. What are we doing? Mark, are you with me, buddy?
Hey, I'm here.
All right.
Where am I?
Yeah, right. Well, how didn't we just do this?
I sort of remember this from like the night before, and then this morning.
Yeah.
Ooh-wee.
Let me lower this music down. People in the chat, just for confirmation, can you hear both myself and Mark? Just
and me.
Sure. Yeah, myself and Mark and me. There is only two people, so let us know if you can hear us.
That's correct.
So what we decided to do is there's no
Crazy.
way. You know, my brain started hurting when I was looking for stuff to ask. I really tried, guys. I really did. But, you know, they're just so in-depth questions, it would just sound totally mocked up and dumb. So what we decided to do was we're just going to go through the flat Earth things point by point. Okay?
Yeah, that's a good idea.
And tell you why that logic or that kind of quote-unquote science is not correct.
I wouldn't even put the word science in the same sentence
Yeah,
as flat Earth.
pseudoscience. Yeah.
Yeah, but yeah, you got it. You got it. That's wise.
So yeah, so it's not really a flat Earth versus globe. I put that on the screen just so. But we are gonna have adult language because I don't think I'm gonna be able to hold back, and mods have asked me about the chat tonight. If they are a flat earther and they want to ask something in the chat, by all means, go ahead. Obviously, we're not going to be able to get to all the questions as we're talking about it.
Right.
So you can let them post. You can, I mean, if they become obnoxious and it's just like the Earth is flat, you know, it's stupid, it's not, you know, if they're obnoxious, go ahead, boot them. You know, but if they're asking like legit questions, we'll try to keep our eyes on the chat and address them as we can. Okay.
After laughing, but
Yeah,
that's okay.
Yes.
I'm
Okay.
sorry because I apologize ahead of time to anyone who is a flat Earth believer. I am usually not very willing to suffer fools lightly when it comes to flat Earth. So I tend to, you know, I'll try to keep the profanity down. I promise.
I won't.
Because I actually don't use
No,
I don't use profanity on a regular basis, you know. But
Yeah.
you know,
Absolutely.
unlike Keith, who claims he does, you know, I really haven't heard him swear a lot, even in private in Pine Bush, you know.
Yeah.
So
I'm
I don't know.
not a big cursor, but I do. So, here we go. Let's start with point number 1, okay?
Right. Yeah,
Which
go for
is, how do I word this? Okay.
it. Without sounding like a flat earther.
Yeah. God. All right.
Just say it.
Okay.
Do your worst. Let's see what
I'm
you can
gonna
do.
try. I'm gonna try this here. Okay. We know that the Earth is a globe. Obviously, there is tons and tons of proof. Okay. Flat Earthers say they know that it's not. Tell me your number 1 point that the Earth is a globe. Your number 1 point right to it that really you can't debunk for any
Okay.
pseudoscience. Okay.
Sure. If it was a flat Earth, then the stars would all be rotating in the same direction. But above the equator, the stars are going one direction, and below the equator, the stars go in another direction, don't they?
Mm-hmm.
Right? Because the issue is when we are here on our planet looking at the North Star does not move. It's another thing. All right?
Right.
So there's a reason why it doesn't move. And you could say, well, we're rotating underneath it. But how come at the equator the stars seem to move faster through the sky, and your telescope has to account for that? Right? And then how come more northerly they seem to move less distance per time, and the telescope has to account for that? Now wait a minute. How can that be? If it's a flat Earth, they should all go the same rate, right?
Mm-hmm. Absolutely.
So they don't, and that's a problem. So I think that the rotation of the stars above in the northern hemisphere versus the rotation in the southern hemisphere, the speed at which the stars move across the sky. I mean, that right there. You know, and then if you want to just keep right on going, the next thing down the list is we know we have the northern lights, the aurora borealis, right?
Mm-hmm.
Well, we also have the aurora australis. Okay, how do you explain those? You know, and from our understanding of physics, we know that the aurora borealis are created by trapped charged particles coming from the sun, entering our magnetic field, swirling around, and the magnetic field comes into the North Pole at the northern celestial pole, and the lines of magnetic force basically spiral those charges down, and when they spiral those charges down, we get this interaction with our upper atmosphere that causes the northern lights.
Mm-hmm.
Well, how come the magnetic field does that? Why do we have that well where the charges come down at this North Pole thing? And how do you account for the fact that it also happens at the South Pole? So that means that at 2 points on this flat Earth, you have to have magnetic fields which are diving down into a pole. And that goes against our magnetic field understanding entirely.
Right.
We can't have that.
With understanding of a flat Earth, it would have to be in the center and then all the way around the edge, because that's, I believe, how they have Antarctica, like a big wall all the way around.
Except we see Aurora or Australis, okay, at the South Pole. And if Antarctica was all the way around the edge, then why is it that at the South Pole, if you take a time exposure, you get star trails just like you get at the North Pole when you aim at the North Pole? That can't possibly work.
Right.
Because it's two different ends of the quote-unquote globe. They're two different ends of the world. And if it's flat, you won't get that.
Well, I'll tell you what. I'm on Mr. Dubé's 200 proofs, okay? And,
I have no idea what that is.
Okay, well, I'm going to read you one thing off and get your thoughts on it, okay?
All right.
Eric says, rivers run down to sea level, finding the easiest course, north, south, east, and west, and all other intermediary directions over the Earth at the same time. If Earth were truly a spinning ball, then many of these rivers would be impossibly flowing uphill. For example, the Mississippi, in its 3,000 miles, would have to ascend 11 miles before reaching the Gulf of Mexico.
Am I really going to answer that?
Yeah, yep, absolutely.
Oh, yeah. This is the problem when you envision a flat Earth. What you throw away is the Earth's topography in lieu of a flat topography. And you have to necessarily change that flat topography to match your model, and that makes your model incorrect. That makes your model have mountains where you can't have mountains. Okay? Mm-hmm. So in that regard, the Mississippi, it runs from high elevation to lower elevation. All right, in the real world, it does. In the real plane, right? But the problem with that is that the circuitous road that this river is taking takes it through all kinds of eddies and swirls and backwaters that it has created over the centuries. A lot of river meanders ended up being cut off, so you have those meander lakes, which are separate little cutoffs, all because of the motion of that river from uphill to downhill. Now, it flows in that direction for a reason, and it's not something that is a unknowable thing. You can measure the altitude of the river from the high end to the low end, and you will see that the river does get lower in altitude. It's going downhill, just like all rivers do. And whether you like it or not, you can take a GPS reading, and that's another thing that the flat earthers will yell about. You can take a GPS reading and get the altitude at any point along the river, and you'll find that you're getting lower and lower and lower until you're at sea level. Now, the problem with the GPS, with the flat earthers, is that they can't explain how GPS satellites can work. They think, and this is their thinking, believe it or not, they think that the GPS GPS transmitters that we see on our phones and everything we use here on planet Earth that jets use in the sky as they're flying are hung by balloons.
Hung by balloons, and I've heard the really tall tower theory too.
Yeah, I mean, I saw one website where a guy was just showing cell tower after cell tower after cell tower saying, these are really the source of the GPS signals. And, okay, if that's true, then how come the GPS coordinate system is based on a sphere? I think that's a little bit of a problem. I think you better really explain that.
Okay.
And I mean, I'm biting my tongue because I know you have more questions to ask, and I can just keep going.
yeah, I got tons.
And I gotta let you talk,
Mr. D'Antonio.
I am so sorry.
So, let's put it this way. The nature of physics.
Oh man, it's just funny when you,
I just
hearing you pretend to talk
oh
like
my,
a flat earther.
I know. I just
That's
okay. Let me try this again.
Go ahead. Try it again.
You see, Mr. Dantiano,
Dantahunio.
the natural physics of water is to find and maintain its level. If Earth were a giant sphere tilted, wobbling, and hurtling through infinite space, then truly flat, consistently level surface would not exist here. But since Earth is in fact an extended flat plane, this fundamental physical property of fluids finding and remaining level is consistent with the experience and common sense, Mr. D'Antonio.
And this is exactly the problem I have dealt with the last time I had a flat Earth debate.
Answer the question, Mr. D'Antonio.
I'm getting there, Mr. Pretend Lawyer. When you look at a sphere, the sphere has gravity. And another thing that flat earthers have a problem with, which relates to everything you're saying, is that people standing in Pennsylvania are standing upright. But if you could see through the world and see people that are now standing where Paul is standing, showing us this gorgeous moon, okay, then you would see that he's on a strange angled away from you. Because he's upright where he is. However, he's on an angle to you. He looks like you're actually kind of looking up his leg and toward his head from below, if you could see him right now.
Are you calling me a pervert, Mr. D'Antonio? This is supposed to be a civil conversation.
Right, so we'll let you take it then, non-civil. The thing is, how this relates is this. Because gravity acts on a mass, a spherical mass, as if it's at the center of that mass, everywhere on that spherical body, directly toward the center, the vector directly toward the center, is where gravity is acting. So, in, say, Indiana, or in areas like that, as the Mississippi River is coming down through that area, the water is seeking its own level in relation to the spherical planet and the gravity that's pulling the water down to the planet. As it goes over the top of the planet, the flat earthers forget that there's gravity everywhere. And, they think that the water is just going to spill over. If it was a spherical planet, that the water would just spill off and fall into space at some point. Because they completely negate, that gravity even exists. To them, their mind isn't capable of harnessing the concept of a spherical body that has gravity. And that right to me says it all. If they can't harness that simple concept, then they are forced to make up, and boy, they truly do make up some funny shit. Oh, I said it. They do make up some funny stuff. And that, one of the things they make up is the fact that the Earth, water can't possibly flow the way it does. And they have an answer for the Coriolis force.
Well,
which,
let me just say, okay, if Earth were a ball 25,000 miles in circumference, as NASA and modern astronomy claim,
yes,
spherical trigonometry, dictates that the surface of all standing water must curve downward at an easily measurable 8 inches per mile, multiplied by the square of the distance. Do you know that, Mark? This means along a 6-mile channel of standing water, the Earth would dip 6 feet on either end from central peak. Every time such experiments have been conducted, however, the standing water has been proven to be perfectly level. Explain it.
Everywhere you go on the planet, standing water will always be perfectly level to your relative position on the planet. Of course that makes sense. That's actually obvious physics.
I declare shenanigans.
Oh, that's because you declare you have no clue.
I object, Your Honor. It's devastating my case.
Everywhere you go on the planet Earth, we call this a normal line. That is the line that comes out from the center of the Earth up through where you're standing. Okay, that's normal. That's a normal line to the Earth, and water will want to be perpendicular to that in standing water. It'll want to be perpendicular to that line coming straight out of the Earth from the center of the Earth. Everywhere you go on the Earth. And that's something that the flat Earth folks can't really grasp for some reason. And I honestly think it's maybe it's sort of a sickness, a mental sickness that where they never really could buy the science. No one ever really explained it well enough to them.
Well, the reason for that, Mark, is because surveyors, engineers, and architects are never required to factor the supposed curvature of Earth into their projects. You know, canals and railways and bridges and tunnels, for example, are always cut and laid horizontally over hundreds of miles without any allowances for curvature. You know this. You're a smart guy.
I know that. And that makes perfect sense. It makes perfect sense. Because when you look at, again, the normal line, that normal line is not the same across the Earth. It changes as you move several miles away, hundreds of miles away. That normal line is angling more toward the center of the Earth from your previous perspective, your original perspective. As you watch it, okay, the normal line coming out of the Earth will be 180 degrees opposite you for the areas on the globe that are directly below you all the way through the center of the Earth and out the other side. The normal line to that side comes out of the Earth that way. And the people down there are upside down. You're looking up skirts. You know, if you're looking at women through the Earth, you're looking up guys' shorts if you're looking at through the Earth that way. So, that's how this works. I mean, that's gravity. And that concept of gravity is something that is hard sometimes for some people to grasp. I don't understand why. Because it's a property of mass that's measurable and is demonstrably showable in an experiment.
Gravity does not exist.
Oh, okay.
Let's just get over that right now, Pilgrim.
Are we going to go through ether? Talk about ether?
I don't know who this ether is you're talking about, but I know that gravity doesn't exist. It's a myth, man.
Keith, you're going to have to read up on the ether part. See, the flat earthers.
Oh, yeah, hold on.
They always blame things on ether.
It's ether, man.
There you go.
I'm trying.
Okay. Do you know that the flat earthers also think that meteor showers are just fireworks?
I love fireworks. They're awesome.
Yeah. And they think meteor showers are fireworks.
Yeah.
Okay.
I can't keep pretending to be a flat earther. It's driving me crazy.
I know it's hard. Well, look. Let's get serious about it for a second.
All right.
Our understanding of gravity, okay, and the way planets form, like the one we're looking at now, okay, the moon, right there, the moon. Our understanding of how that works totally negates the ability to have a flat planet, because gravity would not allow that to happen. Gravity during formation would not allow that to happen. So flat earthers, if they believe it's flat, they also have to believe that something made the Earth other than the universe, other than nature. So they have to invoke another...
it's called Jesus.
Well, yeah, they have to invoke another similarly unprovable tenet to say that this made the flat Earth, and then of course the flat Earth will have to then be 5,000 years old, according to the rest of that. And
there's an ark in Kansas that proves it.
That was built by a guy who just wanted to go to Ararat and he could never go.
I stand corrected.
So, we talked about GPS satellites. We talked about, they think they're hanging on balloons. It's like, yeah, and the jet's way up in the air. You mean they don't run into these things by accident? Oh, hey, I popped the GPS balloon. Okay, coming down.
You know what one of my favorite arguments is, though, is like they sit there and they claim that certain flight paths don't exist. Okay, there's certain flight paths. And the funny thing about that argument is all the ones that they listed, I looked up and found direct flights for like going over the South Pole and
Yeah, you know why they say that? They say that because when they look at an Earth projection, the flights that go from say New York to Los Angeles are not straight lines on the map. They're curved lines, and they say, well, how can that curved line possibly be as efficient as just making a straight line? Well, when you fly in a jet plane over the United States, okay, and you go to, say, Arizona from Connecticut, you sometimes will find yourself crossing over elements of Texas, and if you do a southern route, or you might find yourself crossing over some of the northern states when you do this route. And you say, well, aren't we going out of our way? The answer is yes, if it was a flat Earth. But no, it's a straight line if it's a globe. because the globe is curved and the path projected onto a flat map of the Earth, like in the back of the the American Airlines magazine. Okay, the projected path is going to be a curve when you project that
Okay.
path onto the
Well, let's put
flat
it
map.
this way: if Earth was truly a globe, the Arctic
Yeah.
and the Antarctic polar regions and area, latitude north and south and the equator should all share similar conditions and characteristics. Temperature, seasonal changes, length of daylight, plant and animal life. In my reality, though,
Your reality. Yeah. Go ahead.
the Arctic
I'm
and
waiting.
Antarctic regions and areas, the comparable latitude north and south of the equator, differ greatly in many ways, entirely inconsistent with the ball model, and entirely consistent with the flat model. How you doing?
Hey, the truth is that in all the conditions that actually matter, all the conditions that discuss and point to the physics involved, the North Pole and the South Pole are identical in the way they operate. When it's perpetual sun at the North Pole, it's perpetual night at the South Pole. How do you get that? That comes from the fact that the Earth is on an axial tilt. And that axial tilt, as it goes around the sun, changes the rise and set times of the sun all year long. And at one point, the sun just doesn't quite come above the horizon, and you're in darkness for a couple of months. And that then changes, and you then get the midnight sun, where you have the sun circling the horizon all day long.
Yeah, but I'm going to call bullshit right now. Okay? If the sun circles over and around the Earth every 24 hours, steadily traveling from tropic to tropic every 6 months, it follows that the northern and central region would annually see far more heat and sunlight than the southern circumferential region. Explain that to me, Mr. D'Antonio.
Well, the truth is, at the equator of the Earth, the sun is always hot and always, very warm, because the axial tilt of the Earth doesn't actually affect the equatorial regions as much as it affects the northern and southern regions.
But it's so warm because it's only 3,000 miles away.
What?
Yes.
The sun is 3,000 miles away?
Yeah, it's nowhere near as big as all these NASA shill says it is.
Oh, I see. Well, then that's a problem, because Mercury and Venus don't know that.
It's a spotlight.
And
it's a spotlight. Round
Well, then
and
it's
round we go.
It's a spotlight that shows phases, because Mercury and Venus show phases like our moon shows phases. And, the outer planets do not.
Don't you know that they're projections, Mr. D'Antonio? That's
I
all
see.
projected
That's
up there.
Oh, okay. Well, the truth is, if they were actually projections, then we wouldn't see things like gamma ray bursts reaching the Earth. We wouldn't see other radiation reaching the Earth. We wouldn't be able to see supernovae and then the resulting explosive clouds from the stars that obliterated themselves if they were projections, because it would just be regular stuff. We wouldn't be seeing these things. But the universe is very, very complicated. We wouldn't be seeing near-Earth asteroids that nearly collide with us. We wouldn't be seeing tidal changes the way we see tide changes. There's no explanation for why the tides change in the flat Earth scenario. Well, they'll always find an explanation because that's an obvious one. But the fact is, when you go to the Bay of Fundy and you see that you have tides, and Amanda knows this. She's kind of up there. She's up in like Sydney, somewhere in Nova Scotia,
I don't know
or whatever.
who this Amanda is that you're talking about.
Oh yeah, she's around.
But I will give you the
is,
benefit of the doubt, and I'll take your word for it.
No, I'll tell you more. The Bay of Fundy, you've got several tens of feet of tidal difference in that particular part of the world, and the tides are not the same and not as extreme elsewhere. Now, a lot of that has to do with the geometry of that harbor and so forth, and some of it has to do with the way that the moon interacts with that part of the world and the sun interacts with that part of the world. And Amanda's funny. And I think that if we look at different parts of the world, we have areas in the world that do have different tidal responses to the moon and the sun. And because, as I said, both the moon and the sun cause tides on this planet. It's not just the moon. It's sort of a misunderstood myth. And if the sun was only 3,000 miles away, then we wouldn't have tides everywhere on the planet that we see, because the sun's gravity and the moon's gravity would actually be causing very, very intense tides if that was the case.
There you go with this
because the sun would be only 3,000 miles away. And for the sun to have
gravity and gravity, you keep reciting this gravity. There's no proof that there's any gravity at all.
Actually, I can prove there's gravity if you step outside, go to the top of a tree, and just step off.
That's falling, Mr. D'Antonio. That is not gravity.
Well, gravity results in falling. Yeah. Oh man.
I'm reading through this.
I know.
I think I'm getting.
I don't even know what it is. hey, let's take another one. Okay. They think that space junk and re-entering satellites and the satellites you see that in quote unquote orbit are a myth. They're created by the space agencies to fool you, and it's amazing.
Now you're on my page. Now we're on the same page. I knew I'd transverse you, sir. And every time I look up at Juniper or that other one, you know, the one that has the thingy on it, I knew what I was talking about.
Oh, that's Salvatore, the other one with the ringed planet.
That's what I said, Salvatore.
Yeah, right. The Italian guy. Yeah, I get it.
I said that.
Yeah, okay. Well, if space junk was a myth, all right, and satellites were a myth, then you have to explain something. Why is it that when you see a satellite go over, why do you see it brighten slowly and then fade away? Now wait, if it was a flat Earth, those satellites would see the sun all the time. You would never have anything fading away. So why do we see them fade away? And another thing, when the sun sets at night, anywhere on the planet, when the sun sets in its respective horizon, if you're in the northern hemisphere, the sun's going to set in the west. When it does that, look to the east. What do you see? You see a darkening band of light along the horizon. You know what that is?
I have no idea. You lost me in your first sentence, sir.
Well, typical of flat earthers. You know, I lose them with the slightest science. That band you see at sunset, where the sun goes down, and that band gets higher and higher in the sky. Believe it or not, that is the shadow of the Earth itself.
Bullshit.
And it is not bullshit. It is actually the shadow of the Earth. Now, if I asked you to explain it, you wouldn't be able to explain it from a flat Earth perspective, because it shouldn't happen. It shouldn't happen. So you're seeing a shadow of the Earth on the horizon every single night when it's clear, and it's beautiful. And it goes from orange to purple to darker purple to gray, and you're seeing it in those colors because of the fact that the light coming to you from that area, where there's still some brightness reflecting off some of the sky glow, you're watching it through more and more atmosphere, and what it does is it actually reddens the light because you're seeing it through the atmosphere. That's why sunsets look orange, because there is more scattering taking place. The sky is blue because of something called Rayleigh scattering. So when you look up at the sky, you should technically be able to see the stars and the sun in the sky.
I see them every time I look up.
Right,
Nothing
but
new to me.
You see a star. But whenever the sun is out, we have a blue sky. And we've just accepted blue sky. But what is blue sky? Blue sky is the molecules in the atmosphere are actually taking in some of the energy from the sun, especially those in the blue part of the spectrum, and re-radiating it immediately. This is a spontaneous reaction, but they don't re-radiate it in any one direction. They re-radiate it everywhere. So when these molecules do take this and energy in and then reflect it and radiate it back out, they radiate out the blue part of the spectrum, and they pass through the red, the orange, and the yellow, and part of the green. All right. So this process is something that was found by, of course, a scientist named Rayleigh. And the Rayleigh scattering process causes an excess of blue light to be radiated into the atmosphere by the molecules of air. And that is why we see a blue sky. It's also why we see a red sunset, because when the sun is setting...
Let me ask you, okay?
Yeah?
I've been listening to this bullshit for about 5 to 10 minutes now, okay?
Uh-huh.
What I want to ask you is, what proof do you have that the sun is literally that far away? Because I'm telling you, son, it's 3,000 miles above our head. And I'll tell you why I know that. I know that.
Yeah, I'd like to know that.
Because there's thousands of pictures on the internet showing how sunlight comes down through the cloud cover at a variance of converging angles. The area of convergence is, of course, the sun, and it's clearly not millions of miles away, rather than relatively close, because it's branching out like a pyramid. How you doing?
And you want to hear a really interesting bit of physics about that?
I don't think I do.
You probably won't. When you actually look at those beams that you see coming down, your perspective at those beams, looking at those beams, is such that you think that they're moving at a strange convergent angle like that. They seem to be spreading apart from some light source above the clouds. The fact is, those lines are all parallel. It's a well-known illusion, and you can actually demonstrate it.
Say that again. Parallel.
They're all in line with each other.
Okay. I got you. I'm with you.
They're all parallel, and the thing is, it's because that some of them are coming toward you and some of them are going away from you that you get this apparent angle that they look like they're at, and they're not. It's not true. You're actually seeing the parallel lines. To see this, all you have to do is go up in an aircraft. When you go up in an airplane, you get above the clouds, and you're looking down at the ground, and you see puffy white clouds on the ground here and there. You see that the shadow of the clouds they're all at the same angle from the very distant sun. They're all at the same angle. They're at the same angle because the sun is 93 million miles away, and it's effectively parallel sets of beams.
So you're telling me that it's how many miles away?
It's an astronomical unit, which is 93 million miles, and everybody in chat already knows that.
So you think that we're going to see something that's 93 million miles away? That's what you're telling me right now.
Absolutely. If you look at the stars, you're seeing stars that are many, many light years away, millions of times further than the sun in some cases, and you see those without even needing a telescope.
Bullshit.
So clearly, when you look at this stuff and you look at the sky and the stars, clearly stars have this intrinsic property that's actually called luminosity. That intrinsic luminosity, which actually makes them visible from light years away. Now, to be fair, some stars are hidden by dust clouds inside nebulae and so forth, and you can't see them. But you see some of that. You see some of what's going on because you can see sometimes the illumination caused by the star inside the nebula, and you see this illumination that's causing the light to be a different color. That sometimes is a chemical reaction that's causing the light from a star or light from a nebula to look like it's been reddened through the clouds, and that's actually a property of the hydrogen atom that you're seeing. When you see a stellar nursery, for instance, those are gas clouds in space. As I said, they're called nebulae, and they actually have a lot of hydrogen gas. And when the stars inside are young and energetic, they cause the hydrogen gas to be ionized. And if they ionize, doubly, twice, then they spontaneously give off light that's in the red end of the spectrum. So we end up seeing these quote-unquote H2 regions. H2 Roman numeral 2. So HII, H2 regions. And these H2 regions are the places that are areas typically active with starbirth. And the Lagoon Nebula is one such place. The Orion Nebula is one such place. The Pleiades are not one such place. Why is that? The Pleiades, which are the seven sisters you see at the shoulder of the bull Taurus in the winter sky, that nebula that surrounds those stars is very obvious. You can see it sometimes in a dark sky with binoculars. But that nebula is actually a reflection nebula. It's not caused by gas being ionized and then re-radiating energy out in the red end of the spectrum, like the hydrogen nebula. These are dust grains surrounding these very bright B stars, and these B stars are just illuminating this dust, and it's reflecting back to our eyes off the dust grains, and we see it. So that's called a reflection nebula. So generally, there's two different kinds. There's emission nebula, which is what these H2 regions that show the red are, and there are reflection nebula, which are typically blue, and that's primarily what we got. Well, and that's out.
I just want to make other points too. What about the whole claim that there is no pictures of Earth that aren't CGI or composited or?
Well, that's actually silly, right? Because we can go right now. You can get, if you have an iPhone, you can go download an application this very second. Okay, that application is called ISS HD Live, and you can see the Earth from space, from the ISS live, on two different camera views. As a matter of fact, you see the Earth going by below you, and they say, "Oh, well, they're just using fisheye lenses on the cameras, and it's CGI, it's a studio, it's all this, it's that." Except the Soyuz spacecraft, which are attached to the station that are clearly in the view, are not in any way distorted. They are exactly the same proportions and aspect ratios that you would expect from the Soyuz from seeing them elsewhere. So, then the flat earthers will just come up with another way to talk around that. But the fact is, they're on the losing end. They're at the losing end of this.
But isn't there a Japanese website, like a weather satellite or something, that actually updates a picture of Earth every 60 minutes or something like that? That's pretty far out. That actually gets the whole picture of the globe.
Well, yeah. So do all the NOAA satellites. A lot of the NOAA satellites do that.
And it's live online.
Yeah, you can get that. I mean, but truly live online is the ISS HD feed from the high definition Earth viewing experiment. Now, if Earth was flat and NASA was trying to cover it up, do you really think that they would put a live view from the space station up there? Oh boy, that's a scary prospect.
That's another thing to throw you off, buddy.
That's flirting. That's flirting with the devil. You can't do that. All right. So, yeah.
So let me put it this way: has any flat earther ever gotten you, stumped you?
No.
With anything they have ever said, anything?
No, because they're science free. The only way they've stumped me is by simply being unable to understand the elementary science I'm trying to show them. Like for instance, here's a simple one. If we have a flat Earth, why do we have time zones? If we have a flat Earth, why should we even have differences in time? The sun should be out everywhere or not anywhere.
Well, they have it on different sides of the plate.
I know they do, but different ends of the plate, not different sides of the plate.
Oh, yeah. Mm-hmm.
So different ends of the plate, but wait, if it's flat, it's a star. You can see stars from light years. Why can't we see the sun if it's only just over there, 6,000 miles away, at the other end of the plate?
And on top of that, why does it take, what is it, 8 minutes? From the time we see a solar flare to the time it actually reaches any of our equipment and whatnot.
Don't confuse them.
I'm just saying.
Don't throw science. Don't throw science into this.
I'm Marty McFly.
It makes their heads. It makes them cry.
The point that we're trying to make, people, is that it is easily, mostly common sense that the Earth is in fact a globe. Okay.
It is.
And
right.
any information set forth by a flat earther can easily be debunked by any real planetary scientist. Easily.
Yeah. And you have to ask the question, simple things. I've said this the other night, actually. I said, if the Earth was flat, how come we don't get a call from someone from the edge going, "Oh my God, my dog just fell off the edge," or whatever? Why is it that we don't have any kind of And dang's right, 8 minutes 20 seconds. Why is it that we don't have any reports from the edge, so to speak?
Mhm.
You know, live from CBS, this is Bob Biddle, and I am at the edge of the planet, reporting live from the edge.
Yep.
You know, it's like, you know, and,
Well,
you've never seen that.
Flat Earthers say that there is a militaries guarding the Antarctic wall all the way around. And I was like, do you realize the manpower
That's
you would
a
have to have?
huge. Yeah, we need the population of
figure-
the planet Earth
yeah,
to be able to police that.
One battle cruiser or boat or team usually only covers 10 to 20 miles of a coastline.
Right. Do the
So-
circumference and then figure that out.
Yeah, I mean, that's a massive,
Yeah.
you know,
Oh, I know. Oh, I know.
world
Oh,
military at that.
I got a good one for them. It's aliens. We have entrusted aliens with the policing of the Antarctic wall.
Now we're talking.
Oh yeah, yeah, and don't worry, those planes that fly over Antarctica. Yeah. Don't think about those because you know that just can't possibly be true. You know, absolutely ridiculous. You know, and so it's like I don't think I don't think there's a way to actually win the flat Earth argument. Not without totally negating science and name calling, because that's what it went to when I was actually flying from here. I went to Los Angeles to a symposium and for MUFON, the Mutual UFO Network, and no, we will not try a real debate sometime. And the as I got in. I had a radio show to do almost immediately. I had to rush to the hotel, rush to a conference room. And in the conference room was Lee Spiegel, Nick Pope, me, and a few other folks that were going to be speaking. It was sort of like we were all gathering together to say hi to each other. We hadn't seen each other in a few months. And I'm sitting there, and my phone call comes in. I told him I had to do this debate, and I said, I don't know what I'm debating yet. I don't even know what the topic is. And then I put him on speakerphone. And the host of the radio show, and I think Amanda is probably slinking down in her seat because I think she's the one. Am I right, Amanda? You just put that in chat if you dare. I think Amanda's actually the one that got me on that debate to get me in as the counterpoint. And she'll come up with this in a minute. But anyway, it turned out to be a flat Earth debate. I had no idea. And I was debating this guy at the other end of the phone who had... probably his 16 computers all up with all kinds of facts and figures in front of him to debate me. And all I had was I flew, 6 hours on a plane, on a globe, you see, and landed in Los Angeles, rushed to the hotel, and now I'm in a conference room. I have my key card in my hand. I didn't even get to my room yet, and I have to have a debate now for an hour. So I wasn't even prepared. And when they told me it was a flat Earth debate, you should have seen the look on Nick Pope's face. He opened his mouth and he starts to laugh, okay, like covering up his face a little bit and laughing, and I muted my phone. I looked at him. I said, "Don't laugh, Nick." He goes, "I've got a good one for you. You got to tell him." I go, all right, we'll get to that. So I got into this debate, and this guy just seemed to have all these points lined up, and he's just going on and on and on and on. Boom, 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 boom. And no, Amanda, I did not know at the time that I agreed to it, Amanda, that it was a flat Earth debate. I thought I was debating something else because they didn't tell me what it was about.
By the way, check out Jupiter. It is looking fabulous.
Well, I
Good
see the
job,
moon
Paul.
right now.
Well, you're way behind. You might want to click that live button on your feed.
No, it's going by right now. So I see it going by. I guess I am behind, huh?
It is
Yeah, I
looking
am. Look at that.
Fabulous.
Wow. So anyway, so now they had to go to a break, and yeah, Ken, it's Nick Pope from the UK, and Nick says to me, "Mark, you've got to tell them there is a place on the Earth where you can see that the Earth is flat." And I said, "Really?" He goes, "Yes." And I'm humoring him because I know there's a joke coming. He says, "Tell them that it's in Russia at a place called Lake Uranut." Lake Uranut? Yes. Okay. So I said, "So Lake Uranut?" He goes, "Yes." So when they say Lake Uranut, you say, "Yes, Uranut." That was Nick's big joke. So I used it, and they, of course, didn't get it because they're all serious. They're sweating, their adrenaline's pumping because they think they've got this astronomer on the ropes. And they came back, and I was supposed to do another half hour beyond the first first half hour, whatever it was. And I just hung up. I hung up, and everybody in the room just starts laughing because I couldn't keep it in anymore. I was starting to laugh, and I didn't want to be disrespectful to anybody. But and I'm sure Amanda remembers me hanging up because that means that whoever was on the other end of that had to scramble to, fill in the stuff, to fill in the time. But that's how it went, And it didn't matter what I said. It did not matter what I said. They wanted to have some kind of response. They really wanted to make their point. The Earth is flat, and I think they literally just want to have an argument about something.
Yeah.
I think that's all it is, man.
Yeah.
I really
That's
do.
how it comes off most of the time, It's like, and we told them before, a lot of the ones that come in here, we have had many flat earthers come in and be totally respectful about it. And when, many of us have had a conversation right there in the chat with them, but when they're coming in and just ranting and raving and just calling everything fake, and it's just so annoying. And it's like, you want to come in and have a conversation? Let's have a conversation about it. And, but for the most part, I mean, they are few and far between.
Yeah. They are. It is what it is, and I don't have any reservations about giving them the real science. I don't candy coat it. I just tell them like it is. And they can't answer the questions I ask. They can't answer the question about, okay, well, wait a minute, why do the stars go the wrong way in the southern hemisphere and the right way, another way in the northern hemisphere? How do you answer that? The entire sky is going the other way down there. Mm-hmm. All right. So I'd like to know how that's even possible, if you dare, if you please. And they cannot answer that question.
Well, there's a lot of but what I found is if you bring that kind of stuff up, they'll just deflect it to one of their 200 proofs of a flat Earth or whatever, and like literally we just there just for a little bit. I mean, we were just joking around, but literally you can literally go through that list and just debunk it one by one.
Yeah. Yeah, and I didn't even talk about the sails of the ships going across the sea, getting lower and lower in the water. I mean, I didn't even go around that where you can actually see how the curvature of the Earth affects things, because they always say, well, it's just the currents in the water and all that. Oh, yeah. But that doesn't work because that's not right according to your own theory about the water seeking its own level.
Right. I just think it's stopping progress from happening.
You betcha. You betcha.
When you got people thinking that we're living on a flat plate,
That's 6,000 years old.
Yeah, 6,000 years old. The sun's 3,000 miles away. It's a spotlight sun with a moon, and Antarctica's all the way around this plate, and it's just.
Yeah, but let's see, the aurora australis then doesn't make any sense.
Right.
Because if you go to Antarctica and you look up, you actually see what's called a radiant. The radiant is the location that you can identify visually where the auroras are entering the Earth's North Pole through the magnetic field. You look up and you see the lines radiating in all directions over your head. I've actually seen that. And this is really, really important to understand. When you watch that radiating happening like that, that's happening over your head because you're at the South Pole looking up. Well, if the Earth had this ice wall all the way around its circumference, then why don't you see that everywhere on the circumference? You should. This is the South Pole. Yep. And the answer is that, the aurora australis, which is visible everywhere in Antarctica, somehow has to be some type of another illusion. They have to add in, another illusion.
Even Paul's getting in on it. You see, he's typing in on where the date is. You'll see it come up on YouTube in a little bit. He's like, I know he gets worked up about it too. But you'll see where it says live 528. You'll see Paul adding comments in there.
Oh yeah.
Yeah, he's saying about his scope alignment.
Oh yeah. He's absolutely right. Astronomers know this, but flat earthers probably don't have a telescope. Yeah. They don't know what an equatorial mount is. They don't know like Paul and I know, and other people who have astronomy telescopes know, you have to you have to align your telescope with the north celestial pole. That means one axis points at the North Pole, at the actual pole. Another axis goes, east to west, west to east, and that is done because the Earth is round, and we have telescopes that are following the rotation of this big ball we're sitting on. Again, the normal line is the line from the center of the Earth straight out of the Earth through you, or through the telescope here, which has to be level. If it's level, then you have the normal line out of the Earth goes right through the center of your telescope here, just like it does here at my observatory. Okay, at John Zach Memorial Observatory here, I've got that normal through my pier. So, but my pier would look like it's leaning over on its side if you went 500 miles away and looked back at my observatory with some magic camera to be able to see just the telescope here. Of course, you'd be looking through a little bit of the Earth too, but if you could just ignore all that, you'd see that my pier was on a little bit of an angle, away from you, and it's like,
And somebody,
why is that?
Somebody just asked in the chat, why isn't Jupiter spinning?
It is.
Yeah.
Did you see the red spot? Oh wait, it's gone. But I saw it earlier. Where was it? It was a little more in the center of the planet. Yeah, it spins, but it's 88,000 miles across in diameter. So even though it's rapidly spinning, in under 10 hours or 9 hours around and to go around, it takes a long time. But even as we're sitting here in the chat yesterday, or in the show yesterday, we actually watched the red spot come onto the limb, go all the way around, and be almost near the edge of the limb. We're watching planetary rotation in action, and that's really cool. Absolutely. But it's so large that it looks like it's moving. Fast. It's fast for a big planet, believe me.
Yep. But it's a beautiful, beautiful Jupiter tonight. Really clear.
It really is. You can see, especially up in the. He's got it actually right side up. So that's the north belts up top, and the southern belts down below. Yeah, and that's really, really pretty. You can actually see a lot of delineation in there. And I was using a 20-inch diameter refractor, and that was around 40 feet long or so. And it was so big, I think I told you this, you have to move the whole floor up to meet the telescope. And that's not here. That was at my university, and I was working on star projects in there. And I looked at Jupiter one night, and I just was blown away. And I counted 19 distinct cloud bands, and with a 20-inch refractor, a refractor is the best thing to view planets with. It's all lenses. There's no mirrors. Mirrors tend to be lower contrast, and refractors usually are not what's called high speed, meaning they're not light buckets. They're not a low F number, which means like they can see a lot of stuff when you point them at a star cluster. You might see the brightest stars of a star cluster with a moderate refractor, but all the faint ones you would need this light bucket like Paul has, a Celestron or a Meade telescope like I have, to be able to see these things in all their glory. But when you look at a planet, the lens system is unparalleled. The lens system doesn't put in any artifacts. The focal issues aren't there. The lens is focused down to a singular point, whereas with the mirror systems you have some odd focal issues that you have. And the problem we have here is that with Paul's scope, even unless it's corrected, you might get a strange misfocus of the different parts of the spectrum, the red, orange, yellow, green, blue, indigo, and violet, which is Roy G. Biv, for those of you that want to know how to remember the spectrum. So they might focus at a little bit different locations, and that could cause what's called chromatic aberration. So around the fringes of an object that's like an edge of a building during the day, you might see a little rainbow. Right. On cheap cameras, you see this, a little bit of a rainbow, and that's the chromatic aberration, because they're not accounting for this. Now, that can happen with a refractor or a reflector, but the reflectors have additional problems, and the refractors are far better for viewing planets. That in mind, look at the view of Jupiter in this reflector. This is gorgeous. It's absolutely gorgeous.
Beautiful.
Yeah.
Well, now that we pretty much tackled the flat Earth thing, and we can pretty much say, without a doubt, we can debunk pretty much all that stuff. Since you're here, Mark,
Multiple ways. Yeah.
there are people asking questions in the chat, so it's up to you.
Yeah, I can stick around for a little bit. I may have to walk around a little bit. I want to run upstairs and grab myself a string cheese while we're at it, but that's just,
A string cheese.
String cheese, the things you unwrap and it's got string cheese in it, and then you can hear me going.
Yeah.
I wouldn't do that to you. But no, fine. I can talk to folks if they want to talk.
That's cool. I just see.
Well, I got the 3D printer running in the background here, so I'm watching this, making sure this thing grows right. So I gotta stick around here anyway.
Well, that's cool.
And it's not clear, so that sucks.
I'm trying to look back to find out where that question was. Somebody had asked something about it. But somebody asked about the cloud bands on Jupiter. I think we went through it last night. Why they're going the opposite way.
There's a lot of complicated things going on the planet because, the planet's got cloud bands that in some cases they're deeper than other cloud bands, and some of them are at higher levels and lower levels. Typically, the ammonium ice bands and the ammonium sulfide bands, ammonium hydrosulfide bands and ammonium sulfide bands. Those would be brown, and they're typically in the those lower cloud decks. So when you see the brown bands, they typically are lower, and the white ones are the ammonia ices. Those are actually a little bit higher. You got to keep in mind that the planet is in 3D. If you were orbiting this planet, you would find that the cloud bands are at all these different levels. You could look straight down to the planet, far into the atmosphere in one place, and then you're skimming the cloud tops in another place when you're at the same orbital level. So there's a lot going on there, So that complex interaction with the winds and the way the planet's spinning so fast, that complex interaction will cause these cloud bands to actually move. A lot of convection going on, convection layers. It's warmer in the planet and cooler at the cloud tops. So these speeds got set up, a long time ago, and where they are bordering each other, they actually will cause a lot of turbulence. And when you see the close-ups of these cloud band borders, you will see that there's a lot of stuff that's falling into a lower cloud band, but it looks like a swirl, and it's actually spiraling down into this lower cloud band, and so forth. And these winds and these bands are actually, and not all the bands are moving opposite each other, just so you know. But part of the reason that they're moving as fast as they are is because these adjacent bands are typically rising or falling. All right, and it has to do with the way that the overall convection, if you call it that, in the planet is occurring. And the color I said is due to the chemical composition. You've got winds up to 300 miles an hour in these cloud tops. It's like 150 meters per second or so. And so the interesting thing is that these winds are fairly constant, at each latitude on Jupiter. Not much has really changed, and that's kind of interesting. And we think that there's storms on Jupiter. There's thunderstorms on Jupiter as well. When the probes went behind Jupiter, it actually saw the flashes of light in those cloud decks of lightning. Mm-hmm. So clearly, lightning's being, is running rampant up there. But these winds may be actually driven by the rotation of the planet, which is fast, and the internal heat in the planet. So that complex interaction will cause these cloud bands to take on a life of their own, spin opposite each other, again, rising and falling. It's a very, very complicated planet. It's not just this little meek and mild, little banded planet just sitting there all meek and mild. That's not what's going on.
And us, we're very lucky to actually have it out there deflecting and attracting a lot of stuff.
Remember that? We talked about that yesterday. You're right. And yesterday I made it very clear, and I think it's true, that the planet Jupiter, a big Jovian planet like that, several Jovian planets. I mean, we have Uranus and Neptune, which are gas giants. We have Jupiter, we have Saturn, and those gas giants have served us well because their combined gravity wells and the forces due to their gravity have swept all of these large asteroid bodies away from the inner solar system and many times into the planets themselves, into Jupiter. We saw Comet Shoemaker-Levy hit Jupiter a few years ago, and it hit Jupiter, and every single explosive detonation in the clouds of Jupiter as it exploded was a dark spot, which I watched happen on my telescope. I actually saw them appearing, and I was just astonished with how amazing it was. And these impacts were the size of the planet Earth, every one of them. That means that had that comet hit us, all right, it may not have broken up into smaller fragments because of the massive gravity of Jupiter tearing it apart, as it did. Maybe Earth's gravity would have torn it into two pieces, but we would have got hit with this massive comet. Now, the comet was nowhere near the size of the Earth, okay? But the impact force generates that kind of explosive energy. And that's what we saw on Jupiter, and it was absolutely incredible.
We just had somebody ask about how can you see clouds behind the moon and the sun?
How can you see clouds behind the moon and the sun? We can't see clouds behind the moon and the sun. I'm not sure.
I think he might be talking about maybe an optical illusion. Just like how you can see stars behind the moon sometimes because of the, what do you call it? Now I'm losing the... Now my brain's not working.
Yeah, I mean...
Like gravitational bending of the light around a planet or a star, you know how light...
Yeah, I know what you mean.
Yeah.
Well, the fact is, you need a lot of gravity to do that. And that the amount of gravity that can bend starlight like that is, for instance, the gravity of the sun. But because the sun is so bright, you don't see that except during one special time, and that is during a total solar eclipse. Now, during a total solar eclipse, the scientists did experiments a long time ago to show that light was actually particle nature and had mass, because we saw that the starlight was being bent and refracted around the sun. That shows that light was at a particle nature and that it has some kind of mass, because mass is attracted by gravity. Mass is refracted. An object that has mass can be refracted by, or pulled by gravity, and thus refracted away from its original path. That's what we see. This is how we learned that or part of the reason we learned that we have light that's both wave nature and particle nature. The proof is during a total solar eclipse when you examine the positions of the stars right near the sun during a total solar eclipse. You actually see that they change slightly. And they wouldn't do that unless light itself had mass.
And there you go. I know he asked that question like 6 or 7 times, so I figured I might as well get to it.
Well, no,
I think that's what he was talking about too. I'm not exactly sure if that was what he was talking about, but I'm thinking that might be what he was talking about.
Well, Einstein predicted the light would bend, and it did. He also predicted gravity waves, and we have them. We found them. It took a long time. Yeah, it took a long time, but we finally saw gravity waves, which is great.
Do you know what the first mission or two is for the James Webb? Do you know what it would be doing?
I don't know the James Webb itinerary at the moment, and that'll change because I'm going to be talking to the people that actually are setting up the James Webb Telescope at some point fairly soon, because I want to get involved in some way. I want to be able to help out if I can. I don't know what I can do. Maybe I'll be the janitor. I don't know, but
janitor in a clean suit.
That's right. Did I ever show you the picture of me in a clean suit?
Yeah.
And did I show you that? Because I did the when I did the Google Earth project, I actually had to wear a clean suit for photographing it.
You know what? And, there's another question that we were getting all the time a while back, so I might as well just throw it out there. Why is the moonlight cooler than when in the shade? So I said moonlight is supposedly cooler than shade light, I guess, or something.
And you somehow think that I'm gonna know what that question is?
Yeah. Hey, I've seen it enough to know that question is out there. What they're
Okay, I
talking
mean, I'd
about.
like to understand the question so that I could answer it. You know.
Yeah. Yeah. If you can explain that question a little bit better, or maybe word it a little bit different. I know that there is a question about how moonlight is cool or something like that, but just word it a little bit better where we can actually understand what we're getting into by answering. You know, we don't want to give you the wrong answer. Put it that way.
Yeah, well, I don't think I'd ever give someone the wrong answer, because if I don't know the answer, I'll say so, and if I think I know the answer, I'll say I think this is the answer, but I could be wrong.
Right.
I mean, the fact is, you know, I'm an astronomer. I'm an exoplanet guy. So if I get asked about cosmology and other types of general relativity as opposed to special relativity, if I get asked about that,
yeah, he just said it in the chat. Moonlight is, or Dang just said it in the chat. So moonlight is colder than shaded light because of radiative cooling. So
radiative cooling.
Yeah. So maybe that's what it was all about, I guess.
That's not a question. But I mean, is it the question? Is moonlight colder?
Well, no, I think Dang was answering the guy's question. I think Dang might have understood what he was trying to.
Okay, he might have been around when it was asked. I didn't. I never heard that question. That's pretty strange, you know. But you know, I mean, that brings up another interesting point. Okay, here on Earth, because we have an atmosphere and pressure, especially, we have temperature. Because in the absence of pressure, temperature is undefined. So that means in space there is no temperature. Now that makes the people who don't believe we have gone to space, it makes their heads explode. More than the lack of pressure would in 0G up in orbit. But you know, if anyone who knows chemistry knows the equation PV equals nRT, which is I think it's T to the fourth, and it relates pressure to temperature. The higher the pressure, the higher the temperature has to be, and that's consistent with what you observe. If you puff up your cheeks but don't let any air out and just put pressure inside your mouth, then relax and just go and just let it out, what do you see? You see condensed moisture in your breath, because you've put pressure on that moisture in your mouth and made it come out as a little bit of a fog. You know, you can try it and you'll see, wow, look, I'm smoking, man. You know, and I'll get to space junkies. Is that what it is? SP junkies. I'll answer that in a minute. So, you know, when you're in space, the only thing that matters is radiation and absorption. So this is why when people see ice crystals and ice chips in space off the, say, the ISS or the space shuttle, you know, they say, you know, it's so hot in the sunlight in space, you know, blah, blah, blah. Well, actually, temperature's undefined in space. It's a matter of, when you get into space, it's a matter of how well the object absorbs solar radiation, which heats it internally to cause it to melt and sublimate. Now, if we talk about that, then the argument and the discussion becomes rational, because ice chips in space have a very high reflectivity. That's called albedo. They have a very high albedo. And when you have a high albedo, not much radiation gets into the ice. And so ice crystals and chips that fall off the space shuttle can last for a long time. But when those ice crystals were formed, they were formed on the space shuttle as it was launching. Some of those ice crystals trapped air in there. And as they slowly sublimate in space, sometimes that trapped air is just catastrophically released in a moment. And suddenly that ice crystal, which is floating along lazily, just goes shooting off in another direction, like it was just propelled by a little jet. And the answer is, it was. The air inside is at the 14.7 pounds per square inch pressure that it was on Earth. But when it gets released, it comes shooting out at velocity that's concomitant with 14.7 pounds per square inch. And so it goes shooting off like a little jet. And this answers a lot of the questions about, why did these particles suddenly go off at a 90-degree angle? Well, they're going straight, then they turn 90 degrees. A particle turns 90 degrees. That's right. Not unheard of. In fact, common, frankly, for these things to do that. So, and that has to do with the fact that melting and temperature questions in space take on a whole different meaning, and so people see, these flashing lights that look like they're signaling intelligently. Remember that?
Yeah. Well, were they able to test the what you just said about the ice, like in a vacuum chamber or something? Is that how they came to that conclusion?
Well, that's actually something that was figured out by the physicists who were dealing with how to deal with the ice, because ice can be dangerous. The ice can be dangerous. I mean, it's not going to go shooting through a window. That's not what's going to happen. But it is something that could cause a problem if the shuttle's moving at speed in the atmosphere, and some of the ice were to not come off because it's now warming, and falls back and damages the shuttle. As you know, a piece of foam, damaged the Columbia, right? And we lost the orbiter and the entire crew. So everything is important in space, and so debris following the shuttle around is, of course, of utmost importance. And so astronauts, if they drop the tool, that's worse enough, because it's not like it's going to go flying off to Never Land. It's going to follow around the shuttle. It's not going to doesn't have far to go. It's going to drift slowly away. But if the shuttle makes some kind of orbital correction or anything, it could actually move itself into the path of this, say, a bolt, and it could hit a window and crack a window. If they're moving, because it's all relative. You can't see how fast you're moving when you're up in space. You look out the window and you see the Earth going by below you. You don't realize I'm traveling almost 18,000 miles an hour. And I'm just 500 miles an hour shy of 18,000. That's like fast. And now anything else that's in that orbit is traveling at the same speed that you are. You worry about the things crossing your orbit that are coming up through your orbit. That could be a problem. And that's something that that NASA engineers have had to deal with for a long time, right? I mean, there's no doubt about it. Now I want to go back to that question that Space Junkies, which I know that he said he likes that. Yeah, good. Because that's what it's like, Space Junkies. I like that name. I'm looking for this question that he asked here. Oh, yeah. Origin of the moon, basically. Where'd the moon come from? Well, there's a number of theories. The theory I subscribe to is that the Earth, he was asking, do I believe the moon was once part of the Earth? It makes sense, and I'll tell you why. Because when we look at the moon and do all the analysis of all the materials on the moon, except for what happens to it because it's in the cold, irradiated, UV irradiated space, the composition of the moon is very similar to the Earth's. And so when we see that the moon may have actually been born of the Earth, that was kind of a theory we had, right? And the reason is because we have a planet that has an axial tilt. Maybe that was a result of a collision with a much larger body earlier in its history. And if that body was around the size of like a Mars, then the resulting explosion and release of this object from inside the Earth, that is, the collision would just like slough off this massive chunk of the Earth. Then that's the prevailing theory about what caused the moon. The trouble with that theory is that the moon looks like the Earth. The moon has the composition of the Earth. Wouldn't we expect it to have a composition like the impactor, the thing that hit it? In part. And so far that's elusive. We don't really know. But the fact is, we will be able to get that information eventually, because we're going to be mining the moon. We're going to be going to the moon and doing stuff there like crazy, I'm sure.
Let's see, I'm trying to figure out how long Paul wants to go, because he originally said around 11. So
yeah,
we'll find out. Anyway, any other questions in the chat? We can dip through them. I'm just looking back here. That was a good stream last night too, man. Really good crowd.
I know.
Big crowd.
Yeah. And we had almost 30,000 as of this morning, right?
Yeah.
You know, that's pretty good. I mean, and like you say, you know, if it doesn't take long to add up to 30,000 with people who leave and come in, but that is a lot of views. That's a lot of, you know, I'm sure there's some repeat business in there.
Oh, easily. Yeah, tons. And it's all in the numbers about, you know, watch time and individual
right.
you know, devices and whatnot. But yeah, I mean, just the crowd itself and the chat last night was great.
Yeah, it was.
So, let me see. Seems like everybody's kind of just talking amongst themselves in the chat, back and forth.
Yeah. Oh, that's okay.
How's your 3D printing going?
Very good. It's in the background right now. It's actually, we're printing a house. It's actually not a crater for once. I did print a Eudoxus crater again, and then I have it in the paint room. I'm actually going to paint it up. But you know, I have to encourage people to go out to the United States Geological Survey, and I know I talked to Kenneth earlier here, you know, in the chat. The USGS site actually allows you to do an application called Map a Planet. And you can get craters of the moon. You can also get all the places on Mars. You can also get Ceres and Vesta. You can also get other places. You can get Churyumov-Gerasimenko, the comet that the Rosetta mission landed on. You can get Mercury. You can get these different, you know, and then like 5 or 6 more places that you can actually get the digital terrain maps for, and then print on your 3D printer. And it's really cool. You have to get a USGS ID, and it takes a little while to get it. And as soon as I got mine, I started communicating with the programmers and the people that are actually doing it, because I was finding some quirks in their system, and it was the system I'm using is called Map-A-Planet 2, and Map-A-Planet 2 is a new version of the planetary mapping system that you can use. So you know, you figure out where you want to go. You look at the moon, you know, and you figure out where you want to go. You draw a square around it, and boom, it comes in. And then you have to figure out what kind of projection you're going to use, because you're going to actually want to project the data in such a way that it will print nicely for like a 3D printer. So I use orthogonal projection, and anyone can ask me this moving forward. If you actually do this, I'll help you out with it. And you do an orthogonal projection, and then you make sure it's not too big, because that spells the difference between a 200 megabyte download of your digital terrain map and a 1.5 gigabyte download of your digital terrain map. And I found that the higher sizes, like I know people are like they would say, well, let's just like grab the whole thing and do one whole face of the moon. Sounds like fun, except it only does between plus 60 and minus 60. It doesn't do the poles. It does, but it's a different map entirely, and you also have to get the digital terrain data. That is the elevation models, what they're called, of that area of the moon. And so once you do it, you can print these things out, and you literally watch the moon come to life. Here's the interesting thing: we talked about many times when we actually look at the moon's craters, we say, well, you know, they appear to be all the same depth, right? Mm-hmm. You can prove to yourself that's not the case at all, simply by printing one of these out. Print out an area on the moon where the craters are all, you know, clustered together, and you know, exaggerate the vertical exaggeration. There's a vertical exaggeration factor that you can use. I use 1.5. If you use 1, then you actually see it at the actual elevation it is. But if you use 1.5 and then you turn it into light, you can actually see how the light will fall and how low light angles can create actually some illusions. Well, the craters in the highlands of the moon and the lowlands of the moon are at different depths. And if you get a bordering print, a bordering plate area, you can very clearly see how the craters are all different depths. when you go and you start moving the light across it. It's just the coolest thing. Yeah.
Yeah.
So
is that what you printed the ones I have from?
Absolutely.
Okay.
Yeah.
Yeah,
And we
those
should tell everybody that when Keith and Paul and the other guys came here to our studio, I had all these craters from Mars and the Moon lined up, along with some World War II battle tanks that I couldn't let them take. But
we stole them and ran.
right. And I had all these craters printed out, and I had painted them gray, and I painted them red, reddish orange for Mars. And I said, look, why don't you guys take some of these? You can take one apiece. I let them take one apiece. Then I let them take two apiece afterwards, because they didn't use them all up. I wanted to make sure I get rid of them all of them, so that I can make more. Now the question is, when you look at those prints, is it accurate? And the answer is that it's amazingly accurate, because we're looking at the Lunar Reconnaissance Orbiter data and another probe, Japanese probe called the Kaguya, or Kaguya, and the Kaguya and the LRO data was put together to make a final digital terrain map system. So I used the LRO Kaguya map to get all my data for the Moon, and it's really accurate. And I mean, right down to you have to see the scale of these things to understand. If you keep zooming in and you get a digital elevation map of that one area, very, very tiny area, even if you want, it still has enough data to make it worthwhile. It's incredibly good, high resolution. Now, once you get this, then you have to invest some time learning how to use a program called QGIS, and it's a geographical information system, and I call it QGIS. And QGIS is a program that allows you to manipulate and grab a portion of the Moon image that you downloaded, a portion of that map, and make it an official plate that you can then grow. You can set the plate scale, you can set it to be any size you want, and most important, you have to crop it to make sure that there's no angular outside what's what I want to say, directions that plate goes. It has to be square. That's just a limitation. But you do all that, and then you can set the vertical exaggeration and vertical elevation, and it's amazing. It looks great. One of these days, Keith, you have to put up an image of your craters.
Yeah, absolutely. I plan on actually doing that soon. And I got to tell you, yesterday Heidi was really starting to get worried about traveling or going through customs and everything with that Hubble or that Google satellite.
Telescope. Oh yeah.
Because we were looking at it like, man, if somebody that doesn't know, they could really think this thing looks like a bomb. You know what I mean?
Oh.
And she's
sadly, that might be true. And of course, you scared the crap out of her by saying that.
I didn't
and
do
she
it.
Better not have thrown it in a trash can when she got near the airport because out of fear.
Yeah, I believe she got through and everything was good.
That's good.
So.
Yeah. Well, I mean, look at her. Who's going to think she's a threat? And she'd say, "It's a satellite model, really?" And they'll say, "Oh, okay, go on."
Yeah. But, I mean, can you imagine just, like, seeing that sitting in somebody's bag, like, through the X-ray detector? Like, it would really look like, I can see them.
It would look like it looked like some odd-shaped thing, no doubt about it.
Yeah, with, like, little things sticking out of it, and holes in the top of it, But I can understand why she was worried about it.
Hey, let me tell you, when I had to go to London to do a mini-series for a television program, and I had to bring working radio-controlled submarine models to run in a special effects tank over at Ealing Studios. And these are, square boxes inside fiberglass hulls of submarines. And they're full of motors and wiring and all kinds of stuff that if you didn't know, you would be absolutely certain it was a nuclear device, okay? And so, just imagine. I mean, the customs nightmare getting these things over there was unfreaking believable.
I can imagine.
Oh, it was horrible. And I made wooden crates for these things, and they still managed to break my Alvin submersible. I made an Alvin, which is the little mini submersible that found the Titanic. And you saw it here actually. I have the Hero model sitting up on the shelf. Well, they prodded and pawed at it. In fact, when I got to the studio, I found out that it hadn't even arrived. I'm like, where is it? Oh, it's held up in customs. Oh, let's go, because if they start poking and prodding, and they did, and I got there, and like all these little pieces were broken off. It's like, oh, jeez, the big fat fingered guys, digging in there. What's this? Get your hands out of there.
Yeah, and that's one thing you don't want to tell them. Like, please don't do that. Don't touch that. They don't want to hear that.
Yeah, they don't want to hear nothing to see here. They don't want to hear that.
Yep.
What they want to hear is, here, let me open it up for you. And there you go. There's the whole thing inside here. This little latch that opens it up. And if you explain how it works, then they actually get remarkably calm. So I told them about it, and then I ended up in this long conversation in customs with the smile-free crowd of the customs enforcement officers. Okay, and they're smile-free. And what I did was I actually, ended up talking to these guys, and it's almost like I then had this audience, and I was like now telling them all about the making of a radio-controlled sub and this and that.
You have a habit of doing that, don't you?
I don't know, I guess. But then they started asking me all these questions. I'm like, oh, yeah, well, this does this, it does that. And like, wow, hey, go get Frank. He has to see this. That's just literally, it was the strangest thing. It happens all the time. And, it's like, I don't know, maybe have that kind of face that says, he wants to talk.
Yeah. That's what I seen your first hand up a pine bush.
Yeah, well, up there I'm supposed to have a big mouth, right?
Yeah.
I'm supposed to be talking.
Guess.
Well, they hired me to do it. They hired me to talk.
Yeah, hey.
Yeah.
But just as soon as you started talking, the crowd just started coming around and, getting bigger and bigger and bigger. Even from people, you can tell some people didn't even know who you were, but they were stopped just to listen.
Yeah. Well, I'm glad that I can captivate people about the universe, because that's the most important thing to me.
Exactly.
And when I captivate them in the live streams, it's going to be hopefully the same thing. The only thing I'm worried about is that I'm going to be operating a telescope. In other words, I'm going to be doing what Paul's doing, and I'm going to be managing the live stream, and I'm going to be managing Skype at the same time. So I'm a little concerned that I might drop the ball here or there. So once I get going, we'll see.
Well, it's going to be tough, and as long as because you said you got a good alignment and everything out there, and you should be able to do everything how you want to do it anyway.
Yeah, I mean, if my nightly sky stream is going to be focusing on constellations between Ursa Major and Lyra, then I will align my scope on Doobie, the N star and the Dipper, and Vega. Mm-hmm. And then that means everything around that whole area will be great alignment. Have no problem. Mm-hmm. So, and that's what I'm going to do. And I need clear nights here to test all that out and make sure that works. I have good nights and I have bad nights. Sometimes the telescope doesn't want to go where it's supposed to go. Mm-hmm. But if the alignment's missed, then I got to set it back to a starting position, and then I have to do the alignment all over again. And that boom, another 10 minutes. Yeah. And so once I get an alignment, if I actually can't get an alignment, at some point during the night, what I'm going to do, because I'll have an alignment at the beginning of the night. If I can't get an alignment in the stream, well, I'm just going to push past that and say, look, I'm an astronomer. I know the sky. I'll just find these things by hand.
Right.
If I have to, I can do it. So that's cool. That's all right.
And is it just me, or has the weather been really funky
crappy?
Lately? Yeah, like especially up in Europe, like in the Northeast. It's just been like we had them nice days, when we were up at Pine Bush, but all of a sudden it's like, let's get a rain and cloud pattern going and just keep it that way.
And such is how it's been, and it makes me absolutely nuts. Like, if we look at the 10-day, okay, it's like, well, let's see, Sunday, we had some rain, 30% of rain. Monday, rain. Tuesday, mostly cloudy. Wednesday, 50% chance of rain. Thursday, partly cloudy. Friday, rain. Okay, Saturday, mostly sunny. Sunday, rain. Monday, rain. It's like, what the hell?
Yeah.
It's like Saturday, mostly sunny. And you know what? It'll get screwed up anyway, because Saturday night it'll be clouded up. It'll be a beautiful day all day. And I'll say, oh, good, I'll open up the observatory. As soon as the shutter opens, okay, the clouds go, he's opening the observatory. Quick, guys, let's go. boom,
Yep.
and they're all like up there going,
Just
you
kinda
thought
how
you were
it
getting,
yeah, it's just how it goes.
yeah,
know?
you thought you were getting, yeah, yeah, that's right, yeah, I'm right, yeah, that's right, yeah, I know.
Well, I'll tell you what. What I'm gonna do is I think we're gonna go ahead and end this stream, and so we
Today's
can.
11. It's 10 after 11. Yeah.
Yep. So we can be back tomorrow night, and it looks like I don't know if. Oh no, he got it. Okay, I was gonna say it looked like Paul might have froze up there for a little bit. So he's showing you the Galilean moons. You'll see them pop up on the screen, trying to get you a final shot of that. But yeah, I think we're gonna wrap it up for the night. Thanks again for coming on, Mark. Out of the blue.
Yeah, sure. Yeah, I didn't expect to, but that's fine. I don't mind.
Yeah, it gave you something to do while you're waiting for your 3D printing to get.
Yeah, it's going back there. I gotta, because I have a crater waiting to be printed. Right. So this will be done in about 2 hours. So then I can get that going and then go to bed.
And Mark, go ahead and post something in chat so they have your name. And anybody that wants to subscribe to that channel, he's going to be doing some sky tours, and it's going to be nice. You're going to see some stuff that you ain't never seen it. So click on the Sky Tour live stream with Mark D'Antonio. You can just click his name there and get to his channel.
Can you?
If you want to.
I'm clicking it and I'm not going anywhere.
I think they switched it. You can't do that anymore. I think you actually have to go to the 3 dots to the right of your name.
Oh, really?
Yeah, and you click that, and it says go to channel. So, yep.
Oh, gotcha now.
Yeah, they switched that up for. I guess they were having problem people with spamming and clicking people and whatever. I don't know. YouTube's doing a whole bunch of changing around of their whole live stream thing. I know they're going more the way of Twitch, where coming soon in the future, you're going to have to be a subscriber in order to access the chat that's going on. You can't just just pop in on the chat. You'd have to actually be subscribed to even see it. So, which I think will help a lot. When it comes to guys that just get off. Spamming chats or trolling them. So you never know.
All right, that sounds great.
Yeah, they sent out a whole memo thing on it.
And you know what? When I actually do click the 3 things next to my name, it says remove. And that's all I get.
Really?
It says remove. I don't have go to channel.
I have go to channel, report, remove, put in
for me
out, block, remove.
Oh, okay. So maybe for me, because I'm logged in as me, it doesn't allow me to have that.
Here, let me just get the link. How about that?
Well, it doesn't matter. I mean, if other people can see it. All right. Very cool. Yeah, I enjoy the whole.
Kate has a channel now. Huh? Okay. I just see that.
Oh yeah.
Great.
Yeah.
Any good?
Yeah, she talks about her magnetic anomalies that are in her that she has on her body and stuff. She's good.
All right, here we go. Mark stream link coming. There you go. Now you have it. And still Jupiter looking absolutely gorgeous.
I know, huh?
I think tonight I'm just going to end it on a good shot of Jupiter instead of waiting for it to start blurring out as it gets down the horizon a little bit.
Do you know what Paul uses for these shots? I mean, is it a webcam? But is it a digital zoom?
But if I told you, I'd have to kill you.
Oh, it figures.
We're sworn to secrecy. You know that.
Yeah, well, I'm going to come down and get that Jupiter 2.
Well, what I'll do one time is I'll pull Paul in on Skype with you. And you can exchange notes. Because
I do this. I'm doing the same thing with my camera, whereas I can go in, quite a distance in, quite good magnification, digitally. And I had this new eyepiece projection thing, and I tried it out, and it's not performing the way I like. And eyepiece projection, for those of you in the chat that know about this, eyepiece projection is you have your camera attached to a telescope, okay, but you have an eyepiece between your telescope and your camera. And that eyepiece magnifies the view just like you'd see with your eye. Well, I got this beautiful eyepiece that I bought, and I put the camera on there, and it's like, it's hardly any different. So I kind of got the wrong power. And so I got, oops, I'll have to fix that. But not a big deal, because the views without that are just as good anyway.
We'll get it.
Yeah, we will. I'm not worried.
Absolutely. So yeah, guys, we're gonna end it there. We're gonna shut her down and see you all hopefully tomorrow night. If it's clear, I'm pretty sure Paul will be ready to go as always.
Awesome.
And I'm not sure if he ordered 2 cameras when we were up in New York. I'm not sure if they got there yet, but
Okay.
I can't wait to see what them bad boys do. So, yeah, ladies and gentlemen, we're going to go off. And everybody have a good night. Thanks to the mods. Thanks to the people that were watching. And we will see you tomorrow night.
Thanks, guys.
And
Thank you for the wonderful subscriptions.
Yep.
I appreciate that, and I hope that I helped make your night a little bit more manageable.
Yeah, a little bit.
All right.
And once again, Paul says tomorrow is going to be around 8 p.m. tomorrow night, Eastern Standard Time. So once again,
Awesome.
we'll see you all later. Everybody take care, and good night.